In the previous demos, we had to look at traffic shifting between LLM models using the Glue AI gateway, as well as guardrails and calling out to a NVIDIA NIM microservice for moderation. And in this demo, we're going to take a look at managing credentials for calling these LLMs, what rate limiting looks like, and how to fail over. So again, we are using NVIDIA NIM microservices. The LLM that we'll be calling is this Llama model running in our Kubernetes cluster. We also have our Glue AI gateway, which is handling the proxied requests. And when we come in and make a call to our Glue AI gateway, and this can be anything, it's running in your Kubernetes cluster, so you decide how it gets exposed. It is an AI or an API gateway. So we can ask for flag Arizona in 50 words, or we can ask it a question, this chatbot, which a lot of companies are building internally, and we can see that our traffic indeed does get handled by the Llama model. But what we notice is we didn't send in any security tokens here. If the LLM in the backend needs a API key or some sort of security token, then the Glue AI gateway is handling that. But for clients, for calling the gateway, we don't want to just have it open for everybody. So the Glue AI gateway allows you to configure security however your organization may already do it. You may already be using JOT tokens or things like LDAP or your own API keys, and you don't want to litter additional provider API keys, OpenAI, Anthropic, etc., around your organization. So what we want to do is we're going to configure the AI gateway to require a JOT token. So let's go ahead and deploy that configuration. The JOT token should have specific claims that we'll take a look at here. So now if I call this without using the security token, let's get a different response and call it, we're going to see, hey, that you can't call this because you haven't authenticated properly, or you don't have the authorizations to call this. So let's go ahead and grab a token, JOT token here. We'll add it into our chatbot. We'll say to use it. And let's take a look at the details here. This is a JOT token that has claims to call this specific model. So that's all good. Now if I call it, let's go ahead and submit it. If I call the backend LLM, this should now work. All right, so we get a response, which is great. And now we can start to do things like setting up rate limiting. Rate limiting based on token requests, for example. So if I click on our rate limit demo here and deploy the configuration for rate limiting, give that a second to deploy. And that looks fine, deployed fine. And if we want to take a quick look at that, so we'll go Glue system get rate limit config. Let's go ahead and take a look at that. Per user counter. We'll see that we're going to be doing this based on tokens, and in this case, we'll artificially make the token limit very small. But we have this deployed now. If I send in a request, let's see something about Jerome. If I say submit, this request should go through. We've got our security credentials. Yep, this request should go through, but then any subsequent requests should fail because of rate limits. So let's take a look at, so if I send this in, cross fingers, we should see an error has occurred, and we see we've hit our rate limit. So the last thing that we'll show here is model failover. Let's refresh this thing. For for model failover, what we want to see is maybe our clients are calling a specific model. Maybe it's a provider. It doesn't matter what model, but the use case usually is, hey, we're calling this model. It's a high-end model. It's pretty expensive, but and we have quota around that rate limiting, like we just saw. But maybe the provider is establishing this quota. And if we run out of quota, then we want to fail back to other models, maybe cheaper models. So in this case, we're going to call a GPT-4 optimized model. We'll say, tell me about Scottsdale in 50 words or fewer. And here, let's actually deploy the configuration for failover. And when I send this in, what we'll end up seeing is the request will try the GPT-4 first and then start to fail back to other models. Those other models can be, let's go ahead and take a look at our LLM providers, can be specified, and the failover mechanism specified explicitly in this case. So maybe we're trying for GPT-4, and then maybe it'll fall back to a cheaper model, and then maybe it'll end up at our NVIDIA NIM service that's running locally. Or you might have this flipped, right? Maybe you have NVIDIA NIM, and if that's over capacity, then you can start to fail back to some of these provider models. So we've deployed that. We are going to ask for information about Scottsdale, but in this actual demo, what we're going to see is I'm going to force the rate limiting to apply to GPT-4 and others, and we should end up failing all the way back to our NVIDIA NIM service, which is running Llama. So we click submit, cross our fingers that it succeeds. So far, so good. And we get an answer here. If we look at the raw view, we'll see that the response did indeed go to our Llama model, even though I asked for GPT-4. So thanks for watching this demo. We have a number of other demos. Please check this out on things like guardrails and observability and traffic shifting. So stay tuned.